Hello, welcome students. I am Rekha Thorat, Associate Professor. Today we will discuss on Unit 3. Name of Unit 3 is Infinite Series. First we define convergent series, then divergent series. Let us consider first the convergent series. If sequence Un is sequence of real numbers, then the infinite sum u1 plus u2 plus u3 plus dash 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 plus up to un plus dash 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 up to infinity terms is called infinite series. It is denoted by summation of un, n going from 1 to infinity, or summation of un. Let Sn denotes the sum of n terms of the series summation of un. Hence, Sn equal to u1 plus u2 plus u3 plus dash 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 plus up to un. Sn is called partial sum of the series, and the sequence Sn is called sequence of partial sum of the series. Thus, here S1 equal to u1, S2 equal to u1 plus u2, S3 equal to u1 plus u2 plus u3 dash 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 and so on. That means here un is sequence of real numbers, then the infinite sum u1 plus u2 plus u3 plus dash 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 plus up to un plus dash 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 to infinity terms is called as infinite series. It is denoted as summation of un, n going from 1 to infinity, or only summation of un. Now let Sn denote the sum of n terms of this series, sum of first n terms of this series. Then Sn equal to u1 plus u2 plus u3 plus up to un. Sn is called partial sum of the series, and the sequence Sn is called the sequence of partial sums of the series. Thus, S1 equal to u1, comma S2 equal to u1 plus u2, and S3 equal to u1 plus u2 plus u3 dash 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 and so on. The convergence or divergence of infinite series summation of un depends on the convergence and divergence of the sequence Sn. Thus, if sequence limit of Sn as n tends to infinity exists and finite, then we say that the series summation of un is convergent. That means if limit of Sn, that is means sequence of partial sum exists and finite, then we say that summation of un is convergent. If limit of Sn as n tends to infinity does not exist, then we say that the series summation of un is divergent. Now we consider one example. Show that the series 1 square plus 2 square plus 3 square plus dash 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 plus up to n square plus dash 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 is divergent. Here we have to prove that the series is divergent. This is infinite series. We first consider the partial sum of first n terms, that is sequence Sn equal to 1 square plus 2 square plus 3 square plus dash 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 plus up to n square, addition of first n terms, equal to, this can be written, this addition of square of terms, first n terms, can be written in the form as Sn equal to n into bracket n plus 1 into bracket 2n plus 1 upon 6. Hence, sequence Sn is monotonic increasing sequence. Now we take limit of this sequence. Limit of Sn as n tends to infinity equal to limit n tends to infinity of this n into bracket n plus 1 into 2n plus 1 upon 6, and limit of this bracket is equal to infinity. Hence, sequence Sn is divergent. Hence, This since sequence of partial sum is divergent, given series is also divergent. Now we consider another example. Show that the series un show that the series summation 1 upon n into bracket n plus 1 is convergent. In this solution, we take un equal to 1 upon n plus n into bracket n plus 1, and this can be written as 1 upon n minus 1 upon n plus 1. We know that Sn is addition of first n terms, so first term is 1 upon 1 minus 1 upon 2 plus second term is 1 half 1 upon 2 minus 1 upon 2 plus 1, that is 3, plus up to last term is 1 upon n minus 1 upon n plus 1. And we know that this term and this term cancels with each other, this and next term will be cancelled, and finally we get 1 minus Sn equal to 1 minus 1 upon n plus 1. Taking limit as n tends to infinity, we get limit of Sn as n tends to infinity equal to limit n tends to infinity of 1 minus 1 upon n plus 1 in bracket equal to 1 minus 0 equal to 1. Thus, the sequence Sn is convergent since limit is 1, which is finite and non-zero. Hence, given series un is also convergent. Now we consider one theorem. Statement of this theorem is a necessary condition for convergence of an infinite series summation of un is that limit of un as n tends to infinity equal to 0. Before considering proof, one question that can be asked for objective as the necessary condition for convergence of infinite series summation of un is dash dash. It is limit of un as n tends to infinity equal to 0. That means any infinite series is given, then for convergence we have to check whether the limit n tends to infinity of that series equal to 0 or not. If it is 0, then the infinite series is convergent. Now we consider the proof of this theorem. Let sequence Sn be the sequence of partial sums of this summation of un. Hence, Sn equal to, Sn means sequence of partial sums, that is addition of first n terms. Sn equal to u1 plus u2 plus u3 plus dash 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 plus up to un. Sn plus 1 equal to u1 plus u2 plus u3 plus up to un plus 1. Hence, un equal to Sn plus 1 minus Sn for n is greater than 1. Let the series summation of un is convergent and it converges to S. Hence, sequence Sn is convergent and it also converges to S. Hence, limit of Sn as n tends to infinity equal to S. Hence, since sequence of partial sum has limit S, limit of un as n tends to infinity equal to limit of Sn plus 1 as n tends to infinity minus limit of Sn as n tends to infinity. Since un equal to Sn plus 1 minus Sn, we take limit of both sides. Equal to limit of this Sn plus 1 as n tends to infinity is S, limit of Sn as n tends to infinity equal to S, so that limit of un as n tends to infinity equal to 0. Hence limit of un as n tends to infinity equal to 0. Thus, the necessary condition for convergence of an infinite series summation of un is that limit of un as n tends to infinity equal to 0.